See, up to 2018 in India, there was no mandatory standards. So most of the motors, 100% motors which are manufactured were IE1 or below that efficiency. So when I was the chairman of EMA between the 2012 to 2016 period, I have initiated the action with the Government of India and Commerce Ministry and Powers Ministry to bring the standard at par with the global standard. And that's how we have become the IE2 mandatory in the country from 2018 onwards. So then IE1 and below that efficiency are banned in India for manufacturing as well as import of these motors. So from 2018 onward, now we have moved to almost 5 years we have completed, and probably now the government is in the mood to make a IE3 also mandatory, because most of the developed countries have already completed more than 5 to 10 years in IE3 mandatory. So in India also the time has come to make IE3 mandatory. And today's, as per your EMA statistic, if you take it, out of the total motors in terms of megawatt produced in the country, about 2000 megawatt, out of which almost LT motor I am talking, out of which more than 40% are IE3 plus efficiency and 60% are of IE2, which is mandatory. So as such, market is in the mood to move for IE2 to IE3 plus efficiency. So today what we are going to cover you about the latest technology of this IE5 efficiency. What is IE5 efficiency? Each level of efficiency, when you go up, there is a reduction in the losses by 25%. So IE1 to IE2, there is a reduction in losses by 25%. So means if it is a 80% efficiency, means 20% losses. So when you move from IE1 to IE2, you will reduce that 20% losses by 25%. So 80% efficiency will become 85%, one level. IE2 to IE3, when you go, again the 25% reduction in losses, and so on for IE4 and IE5. So today what we are going to cover you for the latest our development of IE5 energy efficiency motors with the limited range between frame 130 to frame 225 of 3.7 kilowatt to 55 kilowatt, what we have developed for a IE5 efficiency motors. And this is a completely new technology, and even we can claim that we are the globally first to make IE5 motors of the line start. Internationally, IE5 motor available in very few numbers, but those motors require a drive to start the motor, whereas our motor is of line start motor. As a normal induction motor, it starts as an induction motor and run as a synchronous motor at a 1500 rpm 4-pole or 2-pole motor at a 3000 rpm. We have just got on the 15th of January our patent file in 2016 for IE4. We got the patent from the Government of India for IE4 motors, and our next patent is in the queue for IE5 motors also, which we are covering today. So over to my colleague Satish Kadam to show the presentation and start with the IE5.
Yeah, sure. Thank you, sir.
Yeah.
So just a minute, I'm sharing presentation. So is my screen is visible?
Yes, yes.
Yeah, okay.
Make it full screen. So
yeah, sure. So good afternoon. I am Satish Kadam. I am product manager, and basically I am taking care of I4 and I5 motors. So just to so this is the basic agenda of today's presentation or discussion. So to start with the brief introduction of Bharat Bijlee. So Bharat Bijlee is a leading electrical engineering company. We are manufacturer of power transformer projects and different types of electrical motors, drives, and magnet technology machines. So our headquarters it is in Mumbai, Airoli. We are a listed company. So this is the brief introduction of Bharat Bijlee. So then coming to the global efficiency standard implementation. So if you see the efficiency classes, so it starts from I1 standard efficiency, I2 high efficiency, I3 premium efficiency, and then I4 and I5 super premium efficiency and ultra premium efficiency. So if you see the world trend, so now I1 people are not using I1 efficiency class motors. In some countries like India, China, and Korea, still they are using I2 efficiency class motors. But now, as sir has already told, the total market is shifted to I3, means premium efficiency class motors, and I4 and I5 motors. So basically, today we are focusing on I5 efficiency motors, so ultra premium efficiency motor. So we are talking about what is the ultra premium efficiency motor, what the range we are manufacturing, what is the benefits of I5 induction motors, and what is the technology of I5 induction motors. So the I5 efficiency motors, the reference standards is IC 60034-30-1 2017. So these are the different levels of efficiencies. Start with I1 to I5. So now coming to the efficiency difference. So efficiency, if you see the efficiency, for example, if you see 3.7 kilowatt, the efficiency for 3.7 kilowatt is somewhere around 79, and in I5 the efficiency is somewhere around 92%. So here we are trying to show the difference between I1 and I5 efficiency motor, or I2 and I5 efficiency motor. So you can see from 3.2.2 or 3.7 kilowatt to 45 kilowatt motor, the efficiency difference. So for lower kilowatt motor, the efficiency difference is high. Say if you see up to 18.5 kilowatt, the difference is high from I1 to I5. And coming to the higher kilowatt rating, say like if you see the 45 kilowatt, the efficiency difference is slightly lower compared to small rating. So this is the trend of efficiencies, and the I mean to say difference of efficiencies from going to lower class, like I1 to I4, I4 to I5. So for I4 and I5 motors, there are different technologies, and by using these technologies, we are manufacturing this type of motor. So here the comparison between different technology. So the technologies like induction motor, line start permanent motor, synchronous reluctance motor, and permanent magnet motor. So Bharat Bijlee is manufacturing line start permanent magnet synchronous motors. And if you see the difference between line start induction motor and synchronous reluctance motor, the main difference is line start permanent magnet motor start with DOL as well as with VFD. However, if you see the permanent magnet and synchronous reluctance motor, for starting always VFD is required. This is the main difference. Second important thing is starting current. So starting current is line start permanent magnet induction motor is very less compared to induction motor and any other technology motors. Also, you can see the difference between power factor. So the power factor in line start permanent magnet technology is higher than induction motor. So what is the line start technology motor? The line start synchronous motor is the motor is designed such that the motor is start as an induction, and then when it comes to its rated speed, then automatically shifted to the permanent magnet mode, so running as a synchronous motor. The main advantage is it is a line start, means starts you can start this motor by using DOL, and though this is a permanent magnet motor, motor will start as a DOL, and this motor will run as a synchronous motor. So in case of second technology, if you see synchronous reluctance motor, so in synchronous reluctance motor, there is no rotor slot. So the motor is always run with VFD. So this is the main basic difference. So this is the pictorial representation of technology. So in right corner upper side, if you see, this is the line start permanent magnet technology rotor construction. So in rotor, there is a slot, different slots, and inside this permanent magnet is inserted north, south, east, west. So this is the arrangement of rotor. Stator is similar to our induction motor. There is no changes in status. The change in only in rotor. So this is the pictorial representation of the technology. Naik sir, you want to add something in this?
Yeah, here I can only say tell you that the technological difference is in the between induction motor and magnet motors is that the magnet motors are reducing the losses, rotor losses zero. So you're always the bearing is on a very safe area operating. Temperature rise of the motor is very low. Power factor is good. Rotor losses are zero. And the different manufacturers adopt the different technology for putting the magnets. What we have adopted is the geometry of the rotor, that is a patented one, so nobody can copy for next 20 years of this our rotor's geometry. And our motors are having both the option, as Satish said, is of the line start, so it can start as a induction motor and it will run at a synchronous speed of 1500 rpm, and it can run on a drive also, it can run without drive also. Go ahead, Satish.
Yes, sure. Thank you. So this is the payback period calculation of synchronous motor by using this IE5 motor. So this is the energy saving payback calculations if you replace IE2 motors with IE5 motors. So for example, if you see the 15 kilowatt motor, so by considering working hour 7,000 hours per year, say then in that case, after replacement of IE5 motor, we can get the energy saving in kWh. It's somewhere around 5,400. And in terms of rupees, it is 49,000 rupees. So this 49,000 is a saving after replacing this IE5 motors in place of IE2 motors. Also, you can see the difference between efficiencies, like in 3.7 kilowatt, IE2 efficiency is 86.3, IE5 efficiency is 92.6. So 6 to 7% difference is there. Likewise, so this is the energy saving. Now this is the payback period calculation when we replace IE5 motor, when we replace IE1 motor with IE5 motors. So the for 15 kilowatt, the saving is 71,000, and in previous side, if you see the saving IE2 to IE5 is 49,000. However, it is IE1 to IE5 is 71,000. So this is the difference. Again, you can see the efficiency differences. Means in 15 kilowatt, IE1 efficiency is old efficiency is 88.7, and now we are replacing IE5 motors, ultra premium efficiency motor. The efficiency is 95.1%. Now, one important point is this operational cost analysis. So for this 15 kilowatt, we have done the calculations. So the energy saving in rupees is 71,000 if we replace IE1 motors to IE5, and let's see the average life of the motor is 15 years. So considering this, the saving after 15 years is, you can see in terms of lakh is 10.6 lakh. And the another parameters, as you as you see in the screen, the scrap values, tax benefit, fresh warranty, then indirect benefit. So considering all these points, the total saving after 15 years is 11 lakh rupees. So ROI between 8 to 10 months for incremental expenses, and for entire motor it will be recovered in 15 months. So this is only for 15 kilowatt motors. So this is a good saving. So now we are talking about 15 kilowatt motor. So if you calculate this for different ratings, say 22 kilowatt, 30 kilowatt, 45 kilowatt, the saving is more. And the main features of this line start permanent magnet motor is temperature rise of this motor is 20 to 25 degree less compared to any induction motors. So the reliability of this motor is also very high. The life is also high because the motor is running temperature in running condition, temperature rise is somewhere around 55 to 50 degree instead of 70 or 75 degree. So this is the main highlights that in terms of saving, in terms of reliability, you can see the results. This is the total motor population analysis. So we take this, did this analysis based on this EMA figures. So in motors, there are we distinguish this in different frame sizes. So from 0.75 kilowatt to 2.2 kilowatt, the frame is coming 100 frames. So up to 100 frame, the percentage share, motor share market is 10%. Then 112 to 250 means it will come around 3.7 kilowatt to 55 kilowatt range, and the population is if it is 60%, and 280 and above is 30%. So so based on this analysis, or based on this EMA figures, the most of the motors are consumed between this 3.7 to 55 kilowatt motors. So we started our range also from this 2.2 kilowatt to 55 kilowatt motors because the consumption is high in this particular range. So this is new purchase motor analysis. So for i5, the energy saving of payback is if i5 motor would have been produced instead of i2 motors. So in this case, we have considered 4,000 is the average working hours, and the annual and the total quantity is motor quantity is 2,47,500. So in previous slide, if you see the consumption between this 3.7 to 55 kilowatt is 60%. So considering 50% of the total motors, the considering this quantity, the total saving is 8,21,550 MWH. So in NWH in terms of energy consumption. So that means we can save CO2 reduction in CO2 emission is somewhere around 6,098 lakh. Anil sir, can you explain more this slide?
See, what we are trying to promote in the industry is that wherever, see, if you take the 24 by 365 running, that means 8,000 hours plus. We say even 50% of that. So even up to say 4,000 hours per year, if your industry, if you are running any application, you must consider to switch to IE5. And that switching can help the country to save about 800 crore rupees in a year, and the low carbon footprint, even in a limited range of this. And this is also, we are considering only 50% of the population if they shift it. So here, with the industry, we are appealing that you look back at your old motors, which are more than 10 years old motors, wherein frequent repairs has to be done, or where you are not going to get any depreciation now of those motors, and 100% those motors are below I1 efficiency, because those are prior to 2018 motors are there. And those old motors you consider to replace in this limited range of 3.7 kilowatt to 45 kilowatt of this motor. And the three advantages what you will get it. One is the overall ambient temperature, you can reduce it, because heat generated by these motors is half of your induction motors. If induction motor has 75-degree temperature rise, this will have 35 to 40-degree temperature rise. This will not put a burden on the grid also, because the starting currents are lower. Power factor is better of this motor. And because of the lower temperature rise and the zero rotor losses, you will not have any maintenance expenses of bearing replacement or any winding failures. That will not occur. If at all any winding failure occur, it may be because of our manufacturing defect, but not about your usage. It will happen because it can sustain overload condition also. Up to 40% continuous overload condition this motor can sustain. So there are multiple benefits in this motor are available. Also, this motor, when you purchase, every motor what we are supplying is with a suitable for VFD. So otherwise, when you normally buy an induction motor, people will ask that if you want for VFD, you pay 10%, 15% extra price for that. So this is not applicable here. And so even later time also, if you want to use the VFD, you must consider I5, I4 or I5 motor, so that anytime VFD also you can introduce in this. The VFD helps you for two things. One is gives the smoother starting. Whenever motor is running on the partial load also, it gives you the energy saving of that, and also protect from the overloading of the condition. So ideally, wherever continuous running applications and variable load is there, industry must consider to use a VFD. Today, I can tell you with my experience in last 5 years, the penetration of VFD has gone up from 18% 5 years back to 42% today for last financial year, and may touch 50% in a year or two also. So 50% of the motors used in the industry will be with the VFD in next 1 or 2 years time. Go ahead, Satish.
Yes, and one more point I just I wanted to add. In this line start permanent magnet technology, the power factor is very good, and the full load current is less compared to other induction motors. So you can select the one size lower VFD. So that is also one added advantage, and this will help to reduce the initial cost.
See, if you look at this last class rating, that for just go one back, this 45 kilowatt class rating, where the efficiency is 96.3% is the efficiency of the motor is there, and the power factor of this motor is 98 or 99% of is the power factor. 0.98, 0.99 is the power factor. Very close to unity, the power factor of this motor for such a big motor. Go ahead.
Yes. So also this is the calculation considering old installation. So 10 years installation is replaced by this 4-pole rating 3.7 to 45 kilowatts. The total considering this the total saving is somewhere around 6,16,000 MWH, and the CO2 reduction is 5,23,735. So
I can only appeal to the industry that when such a fantastic I4 or I5 motors are available in India, and these motors, when you replace old motors, it can give you a payback between 12 months to 18 months. Depends on your usage of 6,000 hours to 4,000 hours. If you are using more than 6,000 hours, 8,000 hours, it will give the payback in 6 months time also for replacing old motors. And then the life of the motor, if it is 15 to 20 years is the life of the motor, imagine the amount of money you are saving per year.
yes.
Today, energy cost, we are considering 8 to 9 rupees, whereas with the country's demand of the energy and more privatization happening, I am telling you the the next 5 years or 10 years, you will see the CAGR of industrial rates will be more than 5 to 7% of increase in the power tariff rate. Because energy is only thing one is going to be this scared one. That's why government is worried about petrol prices, gas prices, and power prices. So energy saving, wherever you see an opportunity, you must use the energy saving of that. So they say that use BLDC, ceiling fan, use LED. Similarly, use I4, I5 motors for your running of the equipment is more than 4,000 hours. Don't use it for short time rated. But or your where your continuous running between 4,000 to 8,000 hours, 100% consider switching that. We can give you the guaranteed saving working sheet also. If you go on our Bharat Bijlee website, you will find under the synchro word there is a calculator given. In that calculator, you have to just mention your current rating of the motor and the efficiency of that motor. Current whatever is given on the nameplate of the, and you select IE4 or I5 in that, and your number of hours and power. It gives you the complete calculations of that, how much you can save in a year, in a 15 years, in terms of unit, in terms of absolute rupees. Go ahead, Satish.
Yes, yes. And apart from saving, as sir has already told that due to this, the heat generation is less, grid burden is less as the starting current is very low, and the maintenance cost is also low. So these are also additional features along with saving. So coming to the improvements, or what improvements we did in our product to achieve these benefits. So stator and rotor stamping. So as you see, though, we are used the improved slot design, slot combination, and optimize ID/OD ratios. Laminations is thin laminations we are using. So these are some changes or improvement or optimization we did in our stator and rotor stamping design. Also, we have optimized our fan design so that the temperature rise is reduced from 70 degree to 55 or 60 degree. Then magnet also we are using high quality or high grade magnets. So high temperature magnet is selected, and some process improvement we did to achieve this all benefits or features in by using this technology. So the main USP is we can do 40% overload in running conditions. So no one can give this suitability for 40% overload. So in this case, as I already explained you that if you are using one motor to say a blower or fan application, and say for duty point is somewhere around 11 kilowatt. So considering safety factor, OEM is select one size higher or 20% higher motors. So in that case, they will select the 15 kilowatt motor or 12.5 kilowatt motor. But due to these features, you can select same motor, means for 11 kilowatt BKW, you can select 11 kilowatt line start permanent magnet synchronous motor. So this will also give you optimized results or 100% efficiency, means 100% loading. This will help to reduce the initial cost also. And also this will help to select the lower size VFD. So this is the main advantages of this overloading, 40% overloading capacity. Then temperature rise less, so reliability is also good. Low starting current. So in line start permanent magnet, the starting current is in between 600 to 650%. However, in any induction technology motor, the starting current is between 850 to 1000 percentage. So if you see the difference, 600 to 850 or 1000 percentage. So that's why the grid burden is less. So these are the I mean to say is a key features like continuous overloading, temperature rise, and low starting current. Then replacement criteria. So for the motors which are running more than 10 years and the operating hours is minimum 4,000, then where power tariff is very high. So now in metro cities, the tariff is more than 12 or 13 rupees. So in this areas, if you replace the old IE2 or IE1 motors with IE5 or IE4 efficiency motors, then you will get the benefits of saving, and payback period is also less in that case.
Payback will be less than 6 months.
Less than 6 months. Yes. So we are talking about old motors, more than 10 years. So many motors are rewound because of many reasons. So once motor is rewound, the efficiency will drop 1 to 1.5%. If you use constant torque load, 3% extra output, means if you direct couple any synchronous motor to pump, then you will get the motor will run at directly run at 1500 RPM. So you will get higher output. So this is the basic criteria of replacement of old motors with high efficiency, ultra premium efficiency motors. Yes, coming to the references or field references. So this is the energy saving with BBL i5 motor. So we install a 37 kilowatt motor in Bajaj Auto Pantnagar plant, and application is pen booth blower. Motor is running with VFD. So the client will get the annual energy saving, considering 7,000 working hours, is 53,900 units, and saving in terms of annual saving in terms of rupees is 3.5 lakh. So client is
This payback was less than 9 months.
9 months. Now they are replacing all their paint booth motors in coming years. So these are all 37 and 45 kilowatt motors in higher range. So if you see, the difference is in terms of current. So current IE3 motor current is 60 ampere, IE5 motor current is 48 amperes. Difference between power consumption. This is the another motor we have installed, small motor 7.5 kilowatt, which are used for exhaust fan, and the saving is around
30,000
so 4,130 kWh.
rupees you show, that is 30,000.
30,000 rupees. So these motors are running already, and we are regularly in touch with client. So they are happy by replacing this old motor with i5. The energy saving with NTPC Poddar mill. So there we replace 45 kilowatt 4-pole motors, and they will get the annual energy saving in terms of rupees is around 3 lakh. In terms of Vardhaman textile also. Yeah. The main thing is in this NTC, the payback is 10 months. And in textile market, so in Surat textile market, we have replaced so many old I1 and I2 motors with I4 motors, and all are running fine, and they will get the saving benefits with lower payback period, less than 1 year. This is the one Taj hotel case study. So we have replaced old 22 motors with new 22 kilowatt I4 motors. So energy saving in terms of kilowatt, you can see here. So 9,300 is kWh saving. So energy saving in terms of rupees is 1,02,500. this 22 kilowatt motor. So this is the Blue Star case. One more case I have not shown here. Recently, we have replaced one 45 kilowatt IE4 motor in Zydus Lifestyle Ahmedabad plant, and they will get the 10 kWh per hour saving. They have replaced their old IE2 motor with IE5 motors, and the application is pump. This is the Aditya Birla case. So major TFO, as I have already discussing this TFO machines in Surat market and other textile markets, we have replaced around more than 3,000 motors for this TFO applications. Then HVAC blower. Also, we have supplied around 750 motors to airport for HVAC applications through different blower OEMs. Then we have supplied motors to different pharma industries like Zydus, Merck Pharma, ACG Pharma. So now I mean to say there is already awareness of this high energy efficient motors and the benefits of this high energy efficient motors. So in textile and in HVAC segments, so there is now a requirement is coming for replacing old motors with I4 and I5 efficiency motors. So this is the recognition award for I5 motors from CII. Excellence in Energy Management System we have received in 2018. As Anil sir already told that we have received the patent for I4 motors. So this is the certificate. So in India, no one can manufacture motors by using this line start permanent magnet technology. Also, we have applied patent for I5 motors also. So this is the brief summary. So all these motors we have already tested with ERDA. We have certificates for this. Advantage and features as we have already discussed. For small ratings, we can eliminate the VFD, though these motors are permanent magnet motors. And from 3.7 to 55 kilowatt, these motors are one-to-one replaceable motors. Means the frame size is same for existing and this line start permanent magnet. So no need to change the base frame for installing these I4 or I5 motors. Payback is good, less than 12 months for I5 motors. So thank you. This is from our end regarding ultra premium efficiency. So we have covered this technology, features, benefit, some live field trials we have already taken, and benefits. So any questions you can please ask.
Yeah, thank you, Anil sir and Satish. That was great to know that I mean we are having such a good range for I4 and I5 motors, and the results are also fantastic. Now there are many questions that I can see in the in the question answers.
Yeah.
But before we go, I mean I myself have some questions. So let me first have the privilege to ask that. How do we address the tuning issues for this IE5 motors, especially small motors? That is one of the question that I have.
I didn't get you. Tuning for?
Tuning, I mean, there is when VFD and this motor is to be tuned. So
yes, this motor, when you use a VFD, when you use with a VFD, you don't have to use a vector VFD. It's a normal induction motor. VFD will serve the purpose, because this motor starts as an induction motor, run as a synchronous motor. And ideally, it is preferred to use a VFD because it gives smoother starting and on a partial load, better saving of that.
Okay.
You don't have to do separate tuning for this. Yeah.
That is great. That is great. Yeah. So since there are a lot of questions, so let's move on to questions immediately. So let us know whether the present, this is from Anil Bugdani, his question is, let us know whether the present type 2 switchgear coordination is suitable for i4, i5 motors for DOL star delta.
Yes, it is suitable because our currents are lower than I2, I3.
Okay. So here itself I take is another question. What will be the minimum maximum speed permitted for i4, i5 motors?
See, the speed of this motor, of 4-pole motor, is 1500 RPM. When you go 2-pole, it is a 3000 RPM. What you have to do only is that if you are replacing existing motor of where you are using induction motor, the speed is 1440, 1450, 1460. So when you use the VFD, you adjust the frequency to that speed so that you get an actual power saving. Otherwise, you are overloading the motor. If you are you are having a pulley belt arrangement, then you have to adjust the pulley ratio, either replace the pulley or trim the pulley in the speed ratio of 1450 to 1500. When in case of direct shaft mounted load, you have no option but to go for a VFD or to trim the fan or the impeller of the pump. So because unless you adjust the load or same as the 1450 or 1460, you won't get the desired power saving.
Okay, great. Yeah, and now I hope that answers your question, Anil. Now the other question is from Anish. Is magnetic levitation megalev bearings available in i4 or i5 motors?
Not required for that. Not required. Okay. We are using a normal shell bearings only in this.
Yeah, the hope that satisfies you, Anish. And now Ishwar Dutt is asking which size of I1 and I2 motor replacement with energy efficient motor is best recommended?
The range what we have shown is of frame 112 to frame 225 or 250. That is between 2.2 kilowatt to 55 kilowatt. So this is the area where your payback will be faster.
I hope that answers your question, Mr. Ishwar. Another question is from Dilesh Bhatt. At site, it is difficult to measure the efficiency of motors. In such case, when we are opting for motor replacement, what would be the parameter which can demonstrate savings to the company? For example, kilowatt hour per day of I1 vis-a-vis kWh per day of I5 along with the operational data.
You can once you adjust the speed of the i5 motor or i4 motor with your existing induction motor, you can see in the your kilowatt hour also the units direct power consumption. You can see the difference.
Okay. Now there's a specific question from Mr. Anish. Is there any product available for slip power reclaiming slip ring induction motors during braking and starting of heavy mass equipments like steel rolling mill?
No. Slip ring, and nowadays slip ring is getting outdated now with the drives available. In fact, slip ring market is not growing for last 10 years. It is reducing year after year. So people should move away from slip ring to now induction motor with the drive.
Yeah. So Mr. Srinivasulu Golapalli is asking which type of magnets are used?
These are rare earth magnets we are using. Rare earth magnets suitable for 160-degree temperature.
Okay. Now Mr. Gaurav Agrawal has a question. So while we are highlighting importance of IE5 motors, there is a significant share of MSME manufacturers who are still manufacturing IE1 class motors despite ban. Is India prepared to transition to higher MEPS while leaving behind MSME manufacturers? Don't you think we should first address the challenges faced by small manufacturers in manufacturing IE2 or IE3 class motors?
For small, when at a country level, when we made the IE2 mandatory, it was with the consent of the all MSME manufacturers, small manufacturers association also have met us in a meeting with the DIPP and a power secretary, and the consent was of the small scale manufacturer also, because they represent 30% of the industry today also. And these and small scale manufacturers were ready to manufacture the IE2 motors, and for them, if any design support required, the ERDA is giving that design support also for whether IE2 or IE3 also.
Absolutely correct, sir.
They
Mr.
manufacture IE1, it is very wrong thing, and if they get caught, there are heavy penalties on that.
Yes. Mr. Srinivasalu has some questions. What's the air gap for LSPM?
So the air gap is smaller than the induction motor.
And which type of winding is used in LSPM is another question.
The winding is normal induction motor winding, but here it is dual coat wires are used and 100% BPI is done, because we are giving both the option to use VFD or non-VFD.
Yeah. Then Mr. Balkrishnan has a question. What is the reason for drop in efficiency after rewinding of motors? Okay.
To do the rewinding of the motor, you actually cut the winding and burn the stator. Whenever you are burning the stator, the iron losses are increasing of that. Because a lot of grinding is done for the slots also to clean it. So the basic silicon steel coating has gone away with that. So for every rewound motor, you will find the drop in efficiency about 1.5 to 2%.
Yeah. Now again, Anish has a question. How much energy savings in percentage can be realized by switching from belt drive to direct coupling in case of i5 motors?
Belt drive to drive coupling, the maybe about 2 to 3% improvement will come, because there is a slippage losses in the belt coupling is used. And that can be measured only when what kind of belts are used, what kind of coupling, what kind of the distance is between drive equipment and the motor. So anywhere between 1 to 2%, you can get the better saving in the power.
Mr. Aishwar Dutt is asking, what is the cost difference between 35 kilowatt i3 and i5 motor?
In i3 and i5, the price difference will be about 45 to 50%.
Okay. So Balkrishnan is again asking, as
Don't worry about the price difference, that 45-50% price difference, you will get it back with the power saving in less than 8 to 12 months period.
Okay.
And thereafter, the life of this IE5 motor will be 5 to 10 years more than the IE3 motors, because of three reasons. One is of the temperature rise is half of the IE3 induction motor, number one. Number two is the bearing is running at a very cool level, very cool area. Bearings are running. Also, in case of any sudden overloading happens, induction motor cannot sustain more than 2%, 5%, whereas this motor can sustain up to 30 to 40% continuous overloading. So you will not face the problem of burning due to overloading, or bearing lubrication is going away because of the temperature rise. That will not happen, because surface will be absolute cool of the motor.
Now there's one question, like, as the voltage fluctuate in India, does it affect the life of motors with VFD?
No, VFD protects the motor from the fluctuation in the voltage. No? That's why the VFD is more recommended whenever the power fluctuation is high. So because VFD will provide the filtered control power supply to the motor.
Okay.
Your grid pollution will go away with the usage of VFD.
Mm-hmm. Yeah. Another question is, can the efficiency of motors be further increased using different type of bearings?
bearings does not help much for the improvement in the efficiency. Improvement in the efficiency are basically happening with the stator core losses, copper losses, the friction and air windage losses, and stray losses. The reduction in these 4 losses helps to improve the efficiency.
Yeah. Then again, Gaurav Agrawal request you to dwell on some of the challenges faced by MSMEs, like access to design and technology for high efficiency motors. Can technology diffusion not be opened by big manufacturers like BP, AB, ABB, Siemens, etc., for small manufacturers to access?
Technology nobody will open up now because it's a patented technology.
Patented technologies, yes.
The investment in the technology and only technology will not opening up also will not help anybody,
Yes.
because it involves the capital investment also. The processes also, manufacturing process also has to be in a sophisticated environment of that. That's why for the MSME actually the maybe I believe is output restricted up to 15 kilowatt or 20 kilowatt or so. Because the bigger the motor you make it, you need to have the sophisticated machines for balancing, for machining, for stamping, punching, grade, investment in the tools. All those things have associated along with the technology. Process technology is different, product technology is different, and the skill of the manufacturer is also different. So unfortunately, MSME will have certain limitations of capital investment for the plant size, because the turnover has to be supporting to the investment, and there is a continuous R&D required. There are quality checks required for incoming material, outgoing material. Testing sophistication also is required. So MSME is getting help by the government, is giving the help, and ERDA is more so to provide them a technology for IE2 and IE3.
True. Another question is IE4, IE5 motors are available in flame-proof version.
Yes, limited range is available in flame-proof with ATEX CE certified. This is mainly we have made it for export, but we do sell in India also. ATEX CE certified.
Okay. Yeah. Then conductor sizes as a bearing of motor efficiency. How do you come to optimum size looking from economic point of view? This is from Balkrishnan again.
This is again for the, you have to use the software, ANSYS software for the making the optimum size of the wire size with the slot combination. It's a complete mathematics behind that, and the design expertise is behind that. I am not a design expert.
Yeah. And people have asked for emails of Satish sir and Anil sir, so that I am typing in the chat box. And regarding presentations, they will be, this recording will be uploaded on our YouTube channel. So you can look for AEE Western India chapter on YouTube, and the link will also be given in the link, LinkedIn and our future mails also. You will find that. So you can go to channel, subscribe to our channel, AEE Western India chapter, and you can find all the previous recordings also on that channel.
I am appealing only industry to consider switch from old motors to IE4 or IE5 for the benefit of the country first, for energy saving and having the failure minimize or no failure, zero failure, and saving the environment with the ambient temperature reducing half.
So we have covered almost all of the questions, and if there are any questions, so email addresses have been given. You can contact directly to Mr. Satish or Mr. Anil sir. And that was a great session, very interactive, and it rose a lot of curiosity amongst all the attendees, I could say. And we hope that people may soon think of considering the changing of old motors to new energy efficient and I4 and I5 efficiency motors. So Thank you, Anil sir. It
Thanks,
was
Bharat.
great to have you on this forum. Really blessed to have this session from your side, and lot of learnings, lot of takeaways from the session. Hope all of them are useful for others also. So
Sure.
thank you so
very-
much.
Thank you.
Thank you. Very well
Thank
conducted.
you,
Good,
Satish. Thank you,
good
Satish, for all the inputs and great presentations.
Yes, thank you. Thank you, ma'am.